Okay, so this is a very quick problem on torque. So we have an 80 centimeter rod and we want to convert 80 centimeters into meters. So this is going to be 0.8 meters. That's what we'll use. And we have this 5 Newton force that's acting at a 20-degree angle to the rod, as shown here in the diagram. Down here's the pivot, which is the axis. We'll just label this as the axis. That's where the rod is going to rotate from. And the first question is to find the lever arm of this force acting on the rod. So up here I wrote the definition for lever arm. D is referred to as the lever arm, and that's where we get the word leverage from. D is the perpendicular distance from the axis to a line along the force. So we've defined our axis. This is the point where the rod will rotate from, and here is the force. So as it is now, we can't draw a perpendicular distance to the force because there's no way that's going to be perpendicular. So what we need to do is draw a line along the force. So this is, we're just extending the force. There's a line along the force. And now, let's see if I can do a nice perpendicular to that line along the force. So this distance here, that looks pretty good. This distance here is the lever arm. It's the perpendicular distance from the axis to the line along the force. So 0.8 meters is the hypotenuse. That's opposite this 90 degree. And then we have 20 degrees up here. So using trig, the way we solve number one, the lever arm, looking at this triangle in here, is going to be sine 20 times 0.8 meters. Perpendicular distance from the axis to the line along the force. And this comes out as 0.274 or 2736 meters, which I rounded to 0.274 there. All right, so the second question is, what's the torque caused by this 5 Newton force? Okay, so torque is equal to force times lever arm, and this is a cross product. The characteristic of a cross product is the two variables being multiplied must be perpendicular to each other. So if we look here, this lever arm, D, and this force are perpendicular to one another. That always has to be true when you're using the torque equation. So the force is 5 newtons. The lever arm, which is the perpendicular distance to the force, is 0.2736 meters. So this gives us a torque of 1.368 Newton meter, which is the unit for torque. Newton meter is equivalent to a joule, but when you're doing torque problems, we leave this as Newton meter. Don't write that as joule. And I just want to show another way to find torque. The idea is that the force and the distance, force times distance, they have to be perpendicular to each other. So one other way to get torque, so we'll do blue here. So what I'm going to do is I'm going to show the components of this 5 Newton force in blue. So we have this component and we have this component. So those are tip to tail. Let me do that a little better. So we got these components that make up the 5 Newton force. And then this angle in here would be 70 degrees, right? If that's 20, then this is 70. This guy that I'm putting a dot on, this component here is perpendicular to the rod. So another way to calculate torque, an alternate way to find torque, is we could take this component, this guy right here, that's perpendicular to the rod, so he is cosine 70 times 5 newtons, That's the component perpendicular to the rod, and then just multiplied by 0.8 meters, which is the length of the rod. So all I did here is I made the distance, and the 0.8 meters is measured from the axis. That always has to be true when you're calculating torque. The distance you're using has to be from the axis. So the 0.8 meters is perpendicular to this component of the 5 Newton force. And then you get the exact same answer, 1.368 Newton meter.